Happy Garbage Day, everyone.
I was instructed to ask you what makes it happy.
What makes it happy? Well, what makes any day happy, right? I mean, we say, have a good day, have a good night, happy birthday, happy New Year, happy Christmas, right? We say all these things. It's just, I wish for you that your Tuesday is as happy as possible. And pro tip for those of you who are new to the Midwest, do not come to school tomorrow in the clothes you're wearing today. Get your winter coats back out. It will be 30 degrees by this time tomorrow. And yes, it's going to happen. I've had this happen numerous times in my life, and it's why I own as many sweatshirts as I do. Because I go somewhere thinking it's not going to get that cold, and I'm like, oh my God, I got to go buy clothes because I'm going to die. So it's going to be cold. It's February. That is on brand for Iowa. We just got to hang in there until May. May is the best month. May and June is our reward for making it through January and February. And you can all reward yourselves for making it through homework after tomorrow. How's that for a segue? So how is homework going? We have homework. Yeah, it's due tomorrow. Homework 2 over binary. Question? Just scratching. TAs, any common questions you've answered about this that you think would be good to talk about? TAs are also in the Zoom room, by the way, so you can talk to them directly. No? No?
I think it might be helpful to review some of the questions I've been getting are related to like getting the odds ratios and different things like that.
Okay.
Which you can exponentiate, and I think it might be helpful to re-show the code that gives you like the standard error and LINCOM.
Yes, I can do that. So
that wasn't a very good question, but you know what I mean.
It was a suggestion for what to review, which doesn't need to be a question to be useful. Let me grab, this is 2A. Okay, so everything you need to be able to do this homework is in example 2A, all right? You're just taking the code and just extrapolating, modifying it. So there are various questions that ask for things in logits. Let me scroll down until we can get to a model of some kind. Let's do the last model because that one has the most stuff in it. So the model including main effects and 2 interaction terms starting on page 8 of example 2A, just to remind folks how to find things. So if you're using Stata, the logit command will give you everything in terms of logits. Like, yeah, that's the default output that you get. So it will say coefficient, and then all of these things are in logits. If you want to get model implied logits, like what is the slope of a predictor for a moderator that's not the reference group, for instance? Like what is the slope of papers if you are in the low quant group or the medium quant group or the high quant group? The latter are going to be found as linear combinations. In Stata, that's a LINCOM. So the same logic, go to the equation, find all the terms that have that slope, factor it out. What's left is the ingredients for your LINCOM statement. To get the corresponding odds ratios, you can either get your calculator out or preferably do the same logit commands but add 2 little letters, OR. Then the output that you get is entirely phrased in terms of odds ratios. You can do the same thing with any linear combinations to get simple slopes for the non-reference groups in interaction terms by adding OR to the end of your LINCOM. And then those will be odds ratios as well. In R, same principle, the GLM output directly gives you logit coefficients. I showed an example using GLHT as one way that you can build linear combinations to get simple slopes for model implied logit slopes. So those will all still be in logits as well. To get odds ratios, I found a function that does that called odds ratio. So if you feed in the results of your logit model with the rest of this, the first column here, that's your odds ratio. The rest of it is confidence intervals, and you can ignore that. If this code doesn't work for you for whatever reason, here is a workaround that does the exact same thing, more manually. And likewise, if you save the results of your GLHT and then put that into a new column, or you make your own odds ratio, then you can get odds ratios for the linear combinations as well. Any questions that ask about differences, though, you make the difference in logits first and then find the odds ratio. Logits always come first. Differences in odds ratios will not be helpful. Okay, is that what you're talking about? Maybe? Okay.
I also think the link com statement, you can use the OR option as well, and it gives you, I might have missed that because I'm.
You did miss that, but that's all right.
Sorry.
So if you don't have the OR, it's in logits. If you add the OR, it's in odds.
I just wanted to read over it,
Mhm.
that's all.
Yeah, it's fine. It's all good. I don't expect people to memorize this code. Like, that's not an expectation. But figuring out, like, what it looks like and then what to change is what I'm expecting. Because that's how I write code. I find the most similar thing I've done to what I need to do in the past, and then 18 find and replaces later, I've got something that works for my current problem. Find and replace is a coder's best friend. Until you learn how to do things like more automatic-y, like building your own functions and stuff, then that's like better, but we don't need to do that at this point. I've heard that ChatGPT is very good at writing code for things, to some extent, but I had something that I wanted to show you all. So I'm on the Facebook with the rest of the olds, and I'm part of a number of groups devoted to research. So one of them is called Reviewer 2 Must Be Stopped. Another one is the Psychological Methods Discussion Group. There's an M+ group I'm part of, and occasionally I'll pop in and answer questions if there's something that I can type quickly. But someone put a post in the Reviewer 2 group today that made me laugh out loud. It was, is there such a thing as Chat PPT for like automatic PowerPoints? Like, and so someone said, well, I tried ChatGPT to make a PowerPoint. I see nothing wrong with this. And this is, hang on here, the picture that they made. I had to download it and print it because it was hilarious to me. 1 second. I can't get to the picture because my floating meeting controls are in the way. Go over here.
Wow.
All right. So this is the slide. I don't see anything wrong with this. It's fine. I especially like logic regression.
Oh my goodness.
Yeah, and then just the letters just floating out here. They're in logits, you see, they're just floating out in outer space. So I don't know if this simplifies repetition, but I'm pretty sure this is, my job is safe for one more year here, if this is what slides look like coming out of AI. So that made me laugh very hard. Anywho, no ChatGPT yet up in here. Point being,
Email that to me.
I certainly can. Point being, if you find yourself going to ChatGPT to get code for any homework, stop. It's here. I promise you there's an example that you can use instead. You don't have to try and invent the wheel, or reinvent the wheel, as it were. All right. So that's homework 2. Anything we want to talk about? It's due tomorrow? And if you're like, holy shit, how am I going to get it done by tomorrow? I have so many things to do tomorrow. 2 points late. Okay, it's 2 points late if you get it done Thursday or if you get it done in finals week. 2 points. I would say that if you're starting to feel the crunch of the semester, because it is, you know, we're nearing the halfway point, you're starting to feel crunched. In terms of order of priority, homework in this class comes first. Asking questions and doing homework is the most important thing because that will force you to go back over your notes in a way that is different from just passively listening to the lectures. We're waving at people. It's good to be friendly. I appreciate it. You're all making friends. You're commonly crunched and sympathetic. That's right. You're phoning a friend. But point being, if you have time, that's when I would turn to the readings. Honestly, the readings are there as supplementary. Here's some more examples. Here's some more explanations. Here's some tutorial. Like, that's what they're for, so that when you need, like, if you come back to this material 2 years from now and you're like, oh crap, I have to do this for real, Those are extra resources that will help you beyond just my packaged material. But in terms of time crunch, homework first is my recommendation, because that will help you review the material inadvertently if you stumble into a section you don't know how to do. All right, then I'll let this go. So no more homework. This is 2A, we don't need that one either. I've got 2B up here. That's what we want to do. We're talking ordinal. Remember how ordinal works? Do we need to re-go over ordinal? By the way, re-go over means present it as if you've never heard it before, whereas review means like you've heard it once, but let's do it again quickly. Okay, one vote for review. Repeat, please. Okay. So the good news is that basically this slide is all I need to do. So the way that ordinal works, we'll do nominal next, so just ordinal for now. It is, we're going to hack logistic regression for binary and make it work for ordinal. We are going to take our ordinal outcomes and divide them up into a series of cumulative binary submodels. So the first one will differentiate the lowest category from all the others. The second one lumps together the 2 lowest from all the others. The third one lumps together the 3 lowest from all the others, and so on. So if I have 4 possible categories, I need 3 submodels. If I have 5 categories, how many submodels do I need? 4. It's always one fewer. And the question then is, which way is your model going? If the model is predicting the red side, then you would end up with thresholds and slopes. If the model is predicting the blue side, you end up with intercepts and slopes. I have rearranged all of my examples to predict the blue side. It's the most intuitive and it's the most internally consistent. So the hardest part about these models is keeping track of what each submodel is uniquely predicting. So directly then, we get the probability of a 0 as 1 minus this one. Directly, we get the probability of a 3 relative to these ones. But to figure out what the probability of a 1 or a 2 is, we have to go between the models. So the probability of 1, 2, 3 minus 2, 3 then leaves us with what 1 is. And likewise, 2, 3 versus 3 gives us 2. So these are called cumulative logit. That is the name of the link function that goes with this. If you're in the IRT class, this is called a graded response model. The factor analysis class is going to call this a graded response model in a few weeks. It's the same idea. So every response category gets used in every submodel, and we are predicting the transition points, essentially, between the two with a logit. So the red, if you think about this in terms of binary, is like the 0, and the blue is the 1. And because then it's like, is it the 1 or the actual 1? That becomes confusing. So we're going to say the lower category or the higher category, because that terminology holds regardless. Okay, how's that? Let's look at some numbers. So correlations we looked at. Let's do empty model again. Empty model meaning no predictors whatsoever. Estimated for the two sole purposes. Remember what they are? Why would I go to the trouble to fit an empty model with no predictors? 2 reasons. Is the empty model the best possible model I could have or the worst? In terms of predicting these outcomes accurately, they only have an intercept in an empty model. So is it the best I can do or the worst I can do in terms of prediction?
Best.
Oh, we got best? I was going the other way on that one. Because everybody gets the same predicted outcome. That can't possibly be right. But it's our jumping off point. So it's the worst we can do. Yeah, it's the worst model we can have. And in terms of likelihood, it's the shortest we can have. So it's, only place to go from there is up. So that's one reason I would go to the trouble, is to get the height of the data under the worst possible alternative so that I can use it as a point of comparison against any other model that's adding things. If you are a Stata user, you don't have to do this. Stata automatically provides a likelihood ratio test for any model relative to empty. If you're an R user, you do have to do this. Now, do you remember me ranting about software last week and trying to figure out what it was telling me? That's reason number 2. So that you know what your submodels are predicting and which way they're going is why I would fit an empty model. Because if I know what I'm doing, the logits that I get back should correspond to the proportions of the cases in each category in the data. So there is this table right here. We are predicting a 3-option variable for how likely you are to apply to graduate school, where 0 is not likely, 1 is eh, and 2 is very. So the proportion of people who answered 0 is 0.55. The proportion of people who answered 1 is 0.35, and the proportion of people who answered 2 is 0.1. That is going to be my answer key to figuring out what my model is doing. How these proportions get recreated by my empty model tells me what the software is doing. Question? I thought I heard a, no? Just breathing? Okay. It sounded like an anticipatory, like I'm going to take a breath and launch a question kind of thing. Yeah, it's fine. So go logit, go logit, go logit gives me the intercepts, not the thresholds. Go logit, go logit. That's why we're picking go logit, because I want intercepts like God intended. I have a lot of opinions about this. Okay, so these two things, they're both labeled constants. Typo or accurate? How can I have 2 constants? I have 2 categories. I have 3 categories. You're on the right track? Do what?
You have 3 categories.
I do have 3 categories. Why do I have 2 constants?
You just need 2 to divide the 3.
Yes, I only need 2. The reason I have 2 is because I have 2 different models being estimated simultaneously. One model is saying, what is the logit of an answer greater than 0? The other is, what's the logit of an answer greater than 1? So these are literally 2 different intercepts because there's 2 different equations happening at the same time. So these are coefficients directly provided by the model. That means they're in logits. If I had done, I don't even know if it's a thing, go probit, I don't know if that's a thing, but I don't know that it is, then they would be in probits instead. I'm not going to do probits to you. We'll stick with logits. So negative 0.2 in logits tells me the logit of the higher category for the first submodel. So that means an answer greater than 0. The logit for that is negative 0.2. That corresponds, when I do this, what's this called, by the way? E to the power of the predicted logit divided by 1 plus e to the power of the predicted logit. There's a term for that. To go from the model back down to the data. 2-word phrase. First one starts with an I. Inverse logit, yep. All right, Zoomers, is my mic still good? Screen share still good? Yes, okay, excellent. Inverse, close. Inverse, more general than that. This one might be an inverse logit, but the term is more general. Also starts with an L.
Link.
Link, yeah. Inverse link as a general concept. So if you're going from data scale, like probability in this case, up to logits, that's link function. If you're coming back down from logits into probability, that's inverse link. And this is the inverse link for logits specifically. So my constant of negative 0.2 in logits, e to that over 1 plus e to that, gives me a predicted probability of 0.45. That tells me right now I know what my model's doing. Because 0.45 describes the proportion of people who have a 1 or a 2. So I know my first model is differentiating the zeros from the 1s and 2s. 0 versus 1 and 2 lumped together. That's the first submodel. To say that conceptually, my first submodel is going to predict the probability of saying something that's not no. Like no is the first category, and then maybe and yes are lumped together. So it's the logit of not no. I'm willing to consider graduate school at least. The second one is a logit of minus 2.2. That corresponds to a probability of 0.1. That probability matches the proportion of people who answered 2. So my second submodel is differentiating the no or maybes from yes. Okay, now I know which way is up. I know that my model is predicting the logit of greater than 0 or greater than 1. Say that again, please. So I can go, these two numbers are all I need, because this one is telling me the logit of being a 1 or a 2 instead of a 0. And so I know that if this is 1 and 2, then 0 has to be 0.55. Likewise, this one is telling me a 2 specifically, so I know that 0 and 1 have to be 0.9. So because all three proportions sum to 1 and all three probabilities are going to sum to 1, I only need to know 2 of them. The third is determined. So I'm trying to teach you simultaneously strategies and models, because this is an accurate reflection of my experience. I first learned how to use software as SPSS in undergrad. I picked up enough SAS to do multi-level models in graduate school and as a postdoc, and then everybody in the world stopped using SAS except me. And I signed up to do a workshop over the summertime. I was in the University of Michigan's ICPSR thing that they do. I was there for 5 weeks in a row, and I got to the workshop that was 4 weeks long, and I'm like, okay, everybody, here's the SAS code, and they're like, none of us use SAS, all of us use Stata. I'm like, what? So I had a crash course to completely redo all of my materials in Stata that I had never even opened. So I was in the documentation, like, how do I do this in SAS, how do I do this in Stata, like in real time, figuring this stuff out. It wasn't for these models, but it was for other ones. And okay, I learned enough Stata to make that work, but this kind of like troubleshooting, like if I know what it's doing, if I estimate this model and it matches the data, or it matches what I got from SAS. And then for a long time I was doing SAS and Stata, and then everyone's like, you need to do R. Like hell I do, but everyone else is using R, so that's where I'm at. So then I'm literally going, okay, here's the numbers from SAS and Stata. Here's somebody's package in R. Now what do I get back? And do the numbers match or not? And so it's this like trial and error. Oh, what are the numbers now? Oh, this is what it must be doing because I have the numbers. So I don't know what the next thing is. I'm going to have to learn what Python. What are the other ones? There's all these other ones. Julian something. What is it? Java? Yeah, like a programming language. I don't know.
Yes, not for statistics.
What I do know is that I'm not done learning software yet, because there's always going to be a new thing. And I can use the way that I know how to do it to figure out what the new thing must be doing, but that's not a straightforward process. It's really not. So when you're forced with learning the next new thing, these are tools that you can use to make sure you know what the package is doing, especially if the documentation is crappy, like it is in a lot of places. Okay, so now I know, based on these logit coefficients and their conversions into probability, what the model is predicting. It's predicting the logit of 1 or 2 instead of 0 as one submodel, and then the logit of 2 instead of 0 or 1 as the other. O-logit, the standard package, gives me 0.2 and 2.2 instead. The difference is the minus sign. So what do you know about logits that makes this make sense? If my model that's predicting the higher category has these negative coefficients, and I run O-logit instead, and I get the exact same numbers, but they're positive, what must it be giving me?
This is lower.
Say it again? Thresholds?
Yeah, it's for lower.
I'm sorry?
This is for lower.
It's for the lower, exactly.
Yeah.
Exactly. So if you have 1, then you multiply it by -1, you can get the other. There will be homework questions about this on homework 3, I guarantee it. This is what I'm looking for you to know. And what kills me about this version is that, do you know which way the slopes go in O-logit? You would think, because of these, that they predict the lower category, right? Nope. If I had predictors, they predict the higher category. It's backwards. It's internally inconsistent, and that's why I'm not using it. In R, the same issues happen. There's a package called ordinal and several other ones that give you thresholds, and you can't change it. So I went looking and looking and looking and looking until I found something that I could work with, and so I'm using a package called VGLM and the function within it, because it has these extra options in it that I need to do ordinal data analysis. So R, VGLM, with these specifications, reverse equals true means give me intercepts. Now I get the negative versions. However, I pointed this out last time. This is what it thinks my submodels are. The logit of y greater than or equal to 2 and greater than or equal to 3. What are my answer choices again? 0, 1, and 2. There is no universe in which this is right. But that's what it wrote. Okay.
If you recoded it to 1, 2, and 3, would it still spit out 2 and 3? Like, is it a placeholder thing, or is it a...
I think it must be doing an internal reordering to make it 1, 2, and 3. That's the only thing that could possibly make sense.
Yeah.
But the fact that my data are 0, and 1, and 2
Yeah.
is like, that's just really unnecessarily confusing. So M+ does the same thing, by the way. Doesn't matter what your data start as. It's like, oh, I'm going to renumber it for you. Thanks. Yes, and variables can only be 8 characters. I know. I know. Okay. So what if we add some predictors? Let's look at our submodel equations here. What parts are the same across submodels and which parts are different? We'll make this like a Where's Waldo sort of thing. We'll go through it piece by piece. What is y? Same or different? This versus this. We're looking for differences. These are different. Submodels are predicting different things. The first one is an answer greater than 0. It's what's being predicted. The second is an answer greater than 1. What are these things? These are intercepts. If I were given thresholds instead, and I wanted to make an equation with thresholds, that's what I'd do. I would stick a minus sign in front of whatever I were given, because that would turn it into a threshold. And those of you in the SEM class, you're going to see this in 2 weeks. You're going to see equations with minus signs stuck in front of the intercept for this reason, because M+ uses thresholds. How about the rest of the model? It's the same. So this is the idea, what it's called is proportional odds, meaning that the slopes are parallel across the submodels. This model is saying that the effect of GPA on your probability of a decision does not matter which decision it is. The higher one, the end. That's what this model is saying. So we come down to the Stata output. It makes it explicit what you're doing. So if you're predicting an answer greater than 0, here's my 3 slopes. If you're predicting an answer greater than 1, here's my 3 slopes. They're the same. So the logit of answering the higher category is higher by 0.62 per unit GPA. The logit of the higher category, that's all the more specific you can be. The logit of the higher category is higher by 1 in people whose parents went to grad school. The logit of the higher category is higher by 0.06 in people who went to private university, non-significant. Turn those into odds ratios by adding OR. Same thing. Same 3 numbers. Same idea. What's the scale of odds again?
0 to 1.
0 to 1. If I had a positive slope, what can my odds ratio be?
1 to infinity.
1 to infinity. If I have exactly 0, what's my odds ratio? A slope of exactly 0 is an odds ratio of what?
1.
1. A negative slope is an odds ratio of what? A negative slope goes with an odds ratio of what? 0 to 1. So this is what gets tricky. Like if you look at odds ratios on your homework and you're not really paying attention, and you're like, well, they're all positive. I guess that means these slopes are all positive. If it's above 1, that's a positive slope. Here's the same model in R. Parallel equals true means make the slopes all the same across the submodels. And so R condenses the output to give you the 2 separate intercepts, but then just show the slopes once because they operate across all the submodels. Do you remember how I would go about testing this model? Like, does this model significantly predict the decision to apply to grad school? How could I know that as a whole? If I wanted to know not just each coefficient, but overall.
Or log like.
Yes, log likelihood. What do I do with it? Like here is the log likelihood for my model. It's 717. Is that good?
No.
Say it again. Is 717 good?
You actually run the ANOVA function.
Yeah, I got to compare it. These numbers have no absolute meaning whatsoever. They're based on the scale of the outcome. But I know that 717 is what I have now. I know that what it was in the empty model with no predictors was 741. So this is -2 log likelihood, which is what we want to compare. So -2 log likelihood is an index of data shortness. You want smaller is better. So it was 741 in the empty model. Now it's 717, and I need to take the difference. So that's my ANOVA function, as you said. And does this have anything to do with analysis of variance? It does not. You know what's funny is it labels it analysis of deviance. So it should be ANODA. Right? If we're going to go acronyms here, ANODA. So empty versus the proportional odds model, and I had to dig into the documentation because there's types, and had to figure out, I tried like literally like if I say 2, what do I get? If I say 3, what do I get? Oh, type 1 is the right answer according to Stata. Like this is my process. So 24, what is that thing?
-2 log likelihood.
The difference in -2 log likelihood. Give me more words that say the same thing. Like what would it be called on your answers and your homework? What would the question say that this is the answer to? Well, play Jeopardy. Like, this is the answer. What's the question? This is the difference in -2 log likelihood between nested models. I'll give you that. What else is it? Looking for a 2-word phrase. First word starts with a T. Second word starts with an S. I can't ever say that. Test statistic. That's a hard one. And in particular, which distribution is this a test statistic that corresponds to? Chi-square. The difference in log likelihood when multiplied by -2 is approximately chi-square distributed, with degrees of freedom equal to the difference in the number of parameters across models. So if I compare this to a reference chi-square distribution with 3 degrees of freedom, this is the exact p-value. So these slopes are very, very unlikely to be as big as they are if the null hypothesis were true for each that they're 0. Very unlikely. That 24, relative to the empty model, is done for you in Stata. Right here. Likelihood, LR chi2, right there. Okay. And odds ratios, hooray. Okay, and this is the point where we had lost our will to live, so I could let you out like 7 minutes early. That sound about right? Okay, it's only 2:37 though. We should be like willful still, full of will. Non-proportional odds or partial proportional odds is what this extension is called. It's as simple as this. Well, let's not make all the slopes the same and see what happens. Maybe GPA is more important in predicting a decision of yes than it is in predicting a decision of eh.
Just to clarify, Lisa, you were saying the model we were doing before are the proportional odds models.
Yes.
And these ones are not.
That is correct. If the slopes are all the same across submodels, the term for that is proportional odds. Because if you were to make a graph, like the lines would be parallel and differ only by an intercept, no matter which prediction, which submodel you're plotting. So to relax that constraint, to let the slopes be different across the submodels, that's called non-proportional or partial proportional, depending on who you read. Question?
Yes, so is this like putting weights on different predictors? Like each predictor having different weights?
So the question was, is it like putting weights on different predictors? You can think of these slopes as weights because that says how much say that variable has in building a prediction. So I would say we are allowing differential weights. The variables get a different say in each of the submodels. So relative to the previous model, how many new terms have we added? How many new parameters in letting the slopes be different? Zoomers, you can play along too. How much different are the two models here in terms of the previous one with equal slopes and this one with different slopes? Not a trick, I promise. I don't do trick questions.
Your options are between 0 and 4.
Yeah, we'll do a multiple choice. How many say 0? How many people say 3? 3, yeah. Because I had 3 before, and then I let these 3 be different. That means I'm adding 3. So I have a total of 6 slopes now, and I had 3 before. So I might want to know a bunch of different things out of this model. I might want to know, is each of these slopes significant? I'll get that. I also want to know, what's the difference between these slopes? Like, could I make them the same and they're close enough and it's fine? Or would it be hurting the data to make them be the same? Like, they really want to be different. If I come down to the model here, I've removed the PL option from Stata and I've added a new one called gamma. That allows non-proportional odds, different slopes. Zooming in so everyone can see this. The likelihood ratio test right here that's printed by default has 6 degrees of freedom. Does that answer either of those questions as to whether each slope is significant or whether the slopes need to be different across submodels? Does it answer either of those questions? The 6 is your clue. If this is 6 in here, what must this number refer to? And this is me helping you. This is a likelihood ratio test with 6 degrees of freedom. The test statistic it came up with is 28. How many slopes did we say were in our model? 6. What's the degrees of freedom for this test? 6. Not a coincidence. What this is telling you is relative to the empty model. Do the 6 slopes work together to create significant prediction? That's not very helpful. So what Stata does by default is only part of the story. So even in Stata, we'll have to ask for additional comparisons to answer our own questions. Same thing in R. But here's the solution. Note that I have labeled the betas for you out here to help us keep track of what we're looking at. Stata does not do that. That's me. But if we go into the solution, I'm going to make the numbers big so everybody can play. Do I have the notes in here? Did I leave it? Hang on. Let me see what I had room for. Nope. Okay. We're going to do it. Stata one. I like this output better anyway. Okay. Constant. Let's start there. Minus 0.57 is what? That's my intercept for the first submodel. Who's feeling brave? Who wants to try to put some words into that?
Logit of answering greater than 0.
The logit of answering greater than 0, that is correct. Keep talking. For what kind of student?
GPA equal 3. Parents
Do not have a degree?
yeah, and then
And
go
they went
to the
and they
public.
went to
school.
public school. Yes. So the intercept, always the expected outcome when your predictors are 0. But the hard part is what are we expecting here? This is the logit of deciding 1 or 2 instead of 0. Now what happens to that logit in people who have stronger GPAs? Your choices are it goes up or it goes down. Goes up. So per unit GPA, the logit of picking 1 or 2 instead of 0 goes up by 0.56. Significantly. People who have parents with graduate degrees have a higher logit of picking 1 or 2 by 1.08. People who went to private university have a higher logit of picking 1 or 2 by 0.23. Okay, with me so far? Any that you want to hear again or hear differently? The constant? So this is an intercept. It's the intercept for the submodel that is predicting an answer greater than 0, so 1 or 2 instead of 0. And it is also specifically when all of these predictor values are 0. So for somebody with a GPA of 3, whose parents didn't go to grad school, who went to public university, the logit of them saying, at least maybe, is this number right here. And if I want to know what that translates to into probability, I would do e to this number divided by 1 plus e to that number. That's the inverse link that gets you into probability. Let's do this one. Parent graduate degrees. Can I say that people who have parents with graduate degrees are more likely to at least entertain grad school? Because what? This one is significant, actually. The p-value is right there. Yeah, this one's not. This is private. It's highlighted for a different reason, though, for this one. Can I say that people whose parents went to graduate school have a higher probability by 1? Can't say that. You can't ever talk about a slope coefficient in terms of probability. It's the logit that increases by 1. You can say that people with parents who have a graduate degree are more likely to entertain graduate school or have a higher probability, a higher predicted probability, you can say that. But if you want to use this coefficient in a sentence, the sentence has to have the word logit in it. Now, what about the other submodel? Constant here is -2. Is anyone else feeling brave? Zoomers can feel brave too, don't forget. -2 tells me what? It's a logit, right? What submodel are we in? Greater than 1, so it is the logit of saying, yes, go into grad school, instead of no or maybe. Now, who is that the logit for? What kind of student? Same thing as before, because it's the same predictors in this submodel. Now let's look at the similarity across submodels. GPA 3 has a slope of 0.6 in the first submodel and 0.72 in the second. Does that look the same or different to you? Just eyeball it. Yeah, they look kind of close, especially when you look at the standard error around them. Those are kind of big. So I'd be like, that's probably all right. It's fine. How about parent graduate degree? Logit slope of 1.08 versus 0.99. That looks fine. It's close enough. How about the slope of private? Positive 0.23 in the first submodel or negative 0.54 in the second submodel. Now, neither one of these is significant. However, I would have difficulty lumping together a positive slope and a negative slope and calling it good. Like, that seems not okay to me. Now, do I need to have this discussion about the constant? Would I ever lump those together or try to? No, it always stays separate. So this is not visual analysis class, right? This is inference. I don't have to eyeball these things. The Go Logit 2 creator was like, hey, would you like to have significance tests for the differences between these slopes? Why, yes, I would. Thank you. Here you go. So in the alternative parameterization, by the way, that is a fancy word that means how you set up the model. Like, what do you want to get directly versus indirectly? That's a parameterization. I don't know what these words mean, but he's got beta and he's got gamma. Let's just ignore that part. 0.59, 1.08, same numbers. 0.23, 0.23. Okay, so he's repeating the first submodel. That much I know. Now the second one, GPA, 0.12. What's that? Oh, it's the difference between 0.59 and 0.72. So So this second set of output is testing directly how different the slopes are for the same predictor across submodels. And if we look at the p-value column here, lo and behold, we were right on the first two. GPA slope is not significantly different across submodels. The parent degree slope is not significantly different, but the sign matters. So the first one is positive because the second submodel had a more positive slope. The second one is negative because the second submodel had a less positive slope. Homework questions. Because it's not enough to know if the slopes are different, but how? Are they stronger or weaker across submodels? And lo and behold, that one. Hit me. Where's the question? Yes, go ahead. I can scroll up. Mm-hmm.
Does that make a big difference here?
So these are each tested against a slope of 0 as a null hypothesis. And they are going to be in part determined by the number of people in each category. Like the power to detect that difference is going to depend on how precisely each slope is estimated in the first place. For the second one, this is a function of the number of 2's in the data. So if we don't have that many people who pick 2, we're not going to have as much power to say this slope is different than 0. But this is different than 0 at the level of 0.05. This one is not. But the conclusion is that these two slope estimates are not significantly different from each other. That's what this additional output down below is going to tell us. Yeah, it's 3 different things. Are each of them different than 0? And then are each of them different from each other? The one that we were worried about, private, 0.08, 0.058. Ew, that's a tough one. If I want to be strict, it's fine, not the same. However, little too close. And then the constants just get relegated to the bottom of the output here. So it looks like maybe the slope for private needs to be different, and it needs to be different directions, that each of these is non-significant. So if I want to answer the question then, do I need separate slopes as an overall test of the 3? I can ask that with a likelihood ratio test. So this is one in Stata I'd have to ask it for specifically. The non-proportional odds model relative to the proportional odds model, they differ in 3, the extra 3 slopes. And it looks like, nah, on the whole, the slopes are the same. But maybe one of them is kind of on the border. Our folks, you have to do more work. Sorry, take it up with whoever made the package. They didn't have this stuff built in. So here's the one thing that switches. Okay, parallel equals false. That gives you different slopes across all the submodels. And the output is then organized by predictor and submodel. And this is all you get. At least they gave you the exponentiation. Exponentiated coefficients, what do you think those are? Odds ratios, yes, this person gave those to you. So you can thank them later. Here's my likelihood ratio test, a no-duh between the proportional odds model and the non-proportional odds model. So my test statistic is only 4, meaning adding these 3 things did not make the model significantly taller, data significantly taller. To get the differences between the slopes, I need to know if this one is different than that one is different than this one, and this one is different than that one, right? Guess what we get to do? Your favorite, the 0s and 1s. Oh, no, but this one is not quite as bad. So when you see this pattern right here, that's one minus the other. That's what it's doing. So it's using the first slope in the first submodel as the reference and asking how different the second one is from it. So this is comparing the 2 GPA slopes, this is comparing the graduate school slopes, and this is comparing the private school slopes. And here they are. And we come up with pretty much the same conclusion, although the standard errors are going to differ a bit from that of SAS or Stata. Okay, how are we doing?
Can you repeat what the slope differences mean?
Yes. These are differences in the strength of relationship of that predictor across submodels. So like in English, GPA, does GPA matter more if you're predicting, yes, I'm going to grad school, than if you're predicting, maybe and yes together? So these are just differences in the size of the slope, and we're going to get an estimate for that and a standard error and test statistic to go with it. Now, how many submodels do I have in this example? Not a trick. I only have 2, right? Because I have 3 categories. What if I had 5 categories? How many submodels do I have? 4. How many possible ways could each slope differ across submodels? Yeah, there's a formula. I don't remember the formula, but I know what the answer is. 6. He did the formula in his head. Good for you. What's the formula?
I guess.
You guessed? Okay. I know there's an exclamation point in it. Yeah, it's like 4, exclamation point or something. But I always pronounce the factorial sign. It looks like punctuation to me. But anyway, 6. So between each pair of submodels, right, if there's 4 different slopes, pairwise, there's 6 possible comparisons per slope. Now, how many predictors do I have? 3. That's it. Now, if I had 4 submodels and 3 predictors, how many possible slope differences could I be looking at? 18. This gets ugly real quick. So both SAS and Stata were like, hey, would you like me to just figure this out for you, which ones need to be different, and I'll tell you? Yes, please, is the answer. Because what I'm asking it to do is isolate just 2 slopes at a time in each of these lines. And I'm asking, what is the difference of this one minus that one? And then this one minus that one. So I'm starting with the second one minus the first to keep the output in the same direction as what we get out of Stata. So I'm asking for a comparison of the slopes, one minus the other, to test their difference, and then I get a test of whether that difference is different than 0.
A question. For this private 1, private 2,
Yes.
it becomes less positive, right? For the first model.
Yeah, so this one is tricky because of the direction. I would say that the second one is either less positive, or you could say that it's more negative because it switches. Yeah, I will make sure to address that ambiguity in your homework. There will be like one way it goes. Because yeah, like this is like different is kind of how you would say one's positive, one's negative. Whereas like these 2, I would say the first one is less positive or the second one is more positive. And this one, the second one is less positive and the first one is more positive. Yeah, so then the results you get, the first 2 are the ones that are equivalent, and then the last one is the one that's questionable. So you can see the example online. If you're interested in doing this in SAS or Stata, I let it figure it out. There's some options that say, hey, go figure this out, and it runs for a few minutes, and then it comes back with the best model in terms of what needs to be different across submodels and what doesn't. And what it came up with is this one, where only the slope for private needs to be different across submodels. The other 2 are the same, which is what we just found. So then to specify a custom version, I have NPL, meaning, I don't know, not proportional odds, for just that one. So it doesn't have to be all or nothing, they're all the same or they're not all the same. You can have it custom.
Wait, I'm sorry, so the code is like figure it out and then it spits out specify if it needs to be different.
Yes, so
So
I
it gives you
skipped
this
that
slope.
step because
Okay.
it's in the online materials. It has a whole lot of output to it. There's options for that in SAS and Stata, and I could not find it in R. Yep. Now note my wording. I didn't say R can't do it. I said I could not find it. I'm leaving open the possibility that someone's like, hey, my package does that. Hey, your internet, if your package does that, hit me up. I'd like to know about it. So this is what it came up with. And lo and behold, once you allow only the slope for private to be different, it is significantly different. It squeezes back over the under the 0.05 line. Now, why would that change? Think about what you learned initially, what happens when multiple predictors compete against each other in a model. Their contributions reflect the shared amount. So what's left is unique, is what that slope contributes uniquely. The solution that you're going to get back is different if you're forcing these two terms to be the same across submodels than if you're not. So the way the covariance is allocated is going to shift around based on what each slope is. So you can have these things wiggle around like that. Now, however, if I look at the solution itself, does private school matter? No, it's not significant in either submodel. So if this were a real analysis, I'd be tempted to dump it entirely. Because knowing that these non-significant slopes are significantly different from each other does not help me predict this outcome. And then get some odds ratios instead, and there's your final solution. In R, the custom non-proportional odds model is by adding stuff to the false. So false squiggle private is how you say, just let that one be non-proportional. Let that one have different slopes. And there we are. Question or hair?
Oh, no, she's not here.
Okay, carry on.
Is there like standard language to talk about proportional, non-proportional, and then is there like a middle term for this?
Yeah, so I think that's where, like, this would be a partial proportional because one of them is non and the rest are regular. That's how I would say. But in the write-up, so as before, all the way at the end, scroll, scroll, scroll. There's lots of words. For example, I would describe what you're doing. Like, I wouldn't rely on the reader to know what those terms mean. I would just explicitly say, these slopes are different across submodels and this one's the same. Then they can use whatever words they want to describe that. Back up here. Okay, backed up too far. Okay, there we go. So there's the corresponding R output, and then I did one last test to match it with the Stata one, and yes, p-value is 0.03 in that case. Okay, how we doing? Now, how would you explain this to somebody? That's going to be the tricky part. Pictures is usually the answer. But there's going to be a little bit more effort involved in getting predicted values out of this than usual. Because normally we get predicted Y, right? And you make a picture of my predicted Ys, and there's only one kind of Y. Like you're predicting one outcome, the end. And then what we did in the last few weeks, we're predicting one binary outcome, so there's only one outcome. How many different outcomes am I predicting here? I got 2 submodels to predict 3 things. So now there's choices to make in terms of how I describe these predictions. Step 1, get predicted outcomes. In SAS, this takes a lot more work, by the way. I have online examples of that if anyone cares. I'm assuming you don't because no one's using SAS in this class. It's fine. You don't have to care. I know. I'm just going to have to deal with it. I know. I know the folks who work at ITP use SAS, though. I know that. So they're grateful that I like SAS. So in Stata, margins, the end. So the only difference between these lines is right here. Predict XB means make it in logits. If you take that away, it means make it in probability. And do you remember how these things work? This is start here, so start at -1 in increments of 1 inside the parentheses and go up to 1. So I'm saying, can you give me predictions for a GPA of 2, 3, and 4? And can you give me predictions for parent degree no or parent degree yes? And predictions for private school no or private school yes? And that one line spits out 3 by 2 by 2 things, 12 predictions. Now, our folks, you have to work a little bit harder. So I created some profiles here. I have 12 hypothetical people that give me all possible combinations as achieved from this one line of code in Stata. I then made a data frame out of those fake people. I then used the predict function in R on that data frame of fake people and gave them predicted outcomes. So essentially what I've done here is make 12 rows of data for every combination of the 3 by 2 by 2 predictors, and then ask the model to use the coefficients to create a new column called Y. In type equals link is in logits, type equals response is going to be in probability. And because it knows it's an ordinal model, it does the extra work for me. So after renaming the columns something useful, I get these things. So here's my original predictor values. So I'm making predictions for prototypical kinds of people. GPA 3 of 2, 3, or 4, given the centering, and then yes or no for the other 2 variables. So the first column it gives me, I have renamed Y logit GT0, greater than 0. Then Y logit greater than 1. And then it did these for me. It gives you predicted probabilities of each answer. So it does the across submodel rearrangement to be able to do this for you. Otherwise, what you would need to do is, like, this logit is greater than 0. If I convert that into a probability, then the probability of 0 is 1 minus that. And to get the probability of a 1, I would have to go between the 2. So it does all of that stuff for you, which is nice. So then the question is, what do you want to plot? You could make bar charts that show how the probability of each category changes as a function of your predictor. I decided to go with line graphs and stick with the submodels instead. So all of this, by the way, I did in Excel so that it would be as transparent as possible. On the left-hand side are predictions in terms of logits, where I have GPA as the x-axis, and then I have different kinds of people in terms of their profile of public school and graduate degree parents. Same thing over here. This is the probability of greater than 0, which is not. So these top 2 figures are showing the effects of my predictors on the decision to at least consider grad school. Something above no. So as GPA increases, the probability of saying something above no increases as well. The difference between the red and the blue corresponds to the difference between no graduate degree parents and yes graduate degree parents. So the red is the no, the blue is the yes. So that's the effective parent graduate degree in each case. And then the dashed versus solid is illustrating the difference between public and private, which didn't matter much. So I set up these colors and lines deliberately so that I could point to, in my results section, as shown by the difference between the red and the blue lines, da-da-da-da-da. As shown by the difference in the dotted versus solid lines, da-da-da-da-da. The bottom corresponds to the same idea for the other submodel, the logit of versus very. So this is predicting the logit of saying definitely I'm going to apply versus something else, and the corresponding probability. So note the left plots. These are straight lines in logits. This is a linear model in predicting the logit. The effect of GPA is linear. Over here, are these lines straight or are they a little bit bendy? Bendy. Coincidence or consequence? Yeah, why are they bendy?
Call this probability.
Yeah, they're approaching zero. So this is the bottom of that S-shaped curve. They can't keep going. So the closer you get to a probability of zero, the less these things are going to matter. It's not an interaction term, and it's not a nonlinear slope. It is a consequence of this link function, understanding that zero is where it has stopped. So what I'm setting the stage here for with pictures is your homework 5 in this class. You get to pick one of these models and do a data analysis on data you care about. As part of that, I would expect pictures. So all the examples are going to have some pictures in it, so you can figure out how to start making those. It can be any model we've covered in the generalized portion of this class. That will not be due until April, so you can put off thinking about that for a while yet. But eventually, I do want to give you practice analyzing data that are meaningful to you. And I know for a fact we don't have the strength for nominal, do we? Not until Thursday. Okay, questions or comments? Hit me.
So how did you figure out, like, those negative one, negative one, how?
So what I'm entering are predictor values. I did it in a column, but it corresponds to, it's going to be like a row of data essentially. Is like, this is, the first person is somebody who has a GPA of 2, whose parents did not go to grad school and who went to public university. And then the second person has the same profile with respect to these two, but switches their GPA to 3 and then GPA of 4. So I'm showing all possible combinations of low, medium, high GPA, and then 0 versus 1 for each of the binary variables, and that creates like 12 distinct profiles. I am then asking the model to create predictions for those 12 distinct profiles, and then I'm graphing the predictions in logits or in probability.
Yeah, but for the second one, like, why the first 6 are zero? Yeah, why the
Ah.
first 6? Yeah.
So I rotated across GPA first, 2, 3, or 4, 2, 3, or 4. Then this is no graduate degree, yes graduate degree. And then within this, this is public or private. So I've got all possible combinations. The order in which you do it doesn't matter.
So you're saying the private and also do 6, 0, 6, 1.
For which, I'm sorry?
So let's see, this one can also do like a 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1.
Yeah, so long as you've got all the combinations in there. That's the only thing that matters. Because you're trying to set up like a unique profile based on all the possible predictor combinations that are reasonable given the scale.
So the number, the order does not matter.
And not really, as long as you know what you meant.
Okay.
And I ended up making them in the order that corresponded to what would be easiest to make a picture with, in my case. So, okay, so here's what's coming up next couple classes. We get something a little different, folks. I'm going to do nominal, and then I'm going to turn things over to the TAs for a little bit. They're each going to give you an example of research that they've done involving logistic models, Vladimir, binary, and ordinal, Nikki, and describe not just sort of like a presentation of results, but how they got there, how the data steps that had to happen, the coding steps that had to happen, and all that stuff. So you'll get the chance to see an example of real stuff and not canned fake people like this. How's that sound? Sounds good. Excellent. Then let me know if you need anything. Homework's due tomorrow. Hope to see you Thursday. Bye for now. Bye, Zoomers.